CSI webinar. This webinar is on exploring robotics in the context of 5G. In this particular webinar, which has been organized specifically for the purpose of giving you an idea, because on 5G, as we all are very conversant with 4G, but not very much with 5G. So Obijan will discuss the communication aspects of telerobotics with some practical examples and discuss that needs to be addressed on an urgent basis. Just to introduce you, with Obijan, I just briefly tell you what Obijan is doing currently. Obijan Bhattacharya is presently serving as a senior scientist in TCS Research, Tata Consultancy Services, Kolkata. He has been serving TCS and the IT industry for more than 18 years. His current areas of interest are network protocols for robotics and IoT, 5G and beyond technologies, quantum internet, and others. In the past, he has provided technical leadership to several critical projects in India and abroad on implementation of contemporary digital wireless communication protocols. He has authored several peer-reviewed international publications and many patents granted in various geographies. He has played a lead role in representing TCS in the Internet Engineering Task Force, as we popularly call it as IETF, standardization efforts. He led the first ever contribution of TCS to IETF standard. He has received IETF fellowship under the Next Gen Leadership Program of Global Internet Society multiple times. He was designated as Internet Society Resource Person for IETF sensitization in South Asia in 2019. He is also a member of the 5G Application Layer Standards Task Force of Telecommunication Standards Development Society, India. Apart from his regular professional engagements, he is also serving as a visiting faculty of Jadavpur University. He has done his BSc Honours and BTech from University of Calcutta in the field of electronics and information technology. He has done his Masters from Jadavpur University. May I request Obijan to kindly start his presentation. Thank you, Obijan. Thank you, my dear friends. We will start the presentation right away. Obijan, may I request you to start the proceedings, please?
Thank you, sir, for your kind introduction. And am I audible?
Yes,
Okay.
little bit louder will help.
Is it better now?
Yes, better.
Right. So, without much delay, let me start the presentation and let me share my screen. Are you able to see my screen? Can you please confirm?
Yes, sir.
Yes, yes, we can see your
Right.
screen.
Okay. So, what I'm going to discuss today is what does it mean? I mean, why robotics is special in the context of 5G, or why 5G is special in the context of robotics. But before I do that, I'm not sure if you'll be able to get the audio, but at least I want to show you this video. Okay, let me introduce Julio Fugatza. It's our account director from Safety, and together we have been
defining this demo in order to show you the potential of 5G. I hope that you can enjoy our.
Now, let me pause here for a moment. So, as we are talking about 5G, what you are seeing, witnessing right now is world's first physical demonstration of holographic video conversation. So, and this was shot by me while watching it live. So that is why you see the jittery hand movement, etc. So as you can see here, there are two persons on stage, and one person is actually there on stage. This is in Valencia in 2019 June. One person, the person in black, is the one who is present there in the auditorium stage, and the person in green is actually a holographic image of the head of operations for Orange Telecom in Valencia, uh, from 5 kilometers away, right? So there are two nodes. So one is the conference node, and another one is the conference. Another one is the ZT or the Orange office, and there is a line of sight communication with 5G core in between. And this is what you are seeing here is a live
First of all, this is a
conversation
vlog. This is the first live
between these
videography
two. So
call.
one is the holographic image
This is
of the distant person,
we are
and the another
from
one
here.
is the
This is
physical
software,
presence of
but
the person.
remotely
And as you can see,
here.
both are
But we are going
interacting
for you.
as
So
if
first of all, for
they
you,
are
please
just in
explain
front of each other,
the
right?
technical strengths of 5G behind
Now,
this demo that we are.
this basically, I have I have I have uh, I have decided to show you this video basically to make you understand the the potential strengths of 5G, which 5G really boasts about. So one is extremely broadband communication, and the other thing is that extremely low latency. So these are the two major things that 5G definitely boasts about. So one is that to have this kind of a 3D holographic image, you need immense bandwidth, right? And while this person is talking to this holographic image, the image is also reacting almost instantaneously or spontaneously. So you need extremely low latency. So we are talking about 1 millisecond latency. However, having said that, this is really not what is going to happen right now, because this is just a one hop connection between two nodes. Okay, one hop line of sight connection between two nodes with the 5G core. Now assume the entire internet to behave this way, where there are hundreds of kilometers of distance between these two nodes. Can we achieve something like this? And that is tricky, and that is not yet solved. So 5G promises are definitely there at a certain limit, but there is still a little bit to be done to make it really realizable and scalable in a global sense, right? And we'll try to understand this aspect as we move forward,
Okay, let me
right?
introduce.
Now, why we talk about robotics and 5G right now? Because the pandemic, in the meantime, actually created a peculiar paradox. So you need to be social, but at the same time, you need to be safe. So that is a paradoxical situation that the pandemic has put us in. So the social distancing basically violates the basic norms of human civilization, which is you need to mingle with each other to form the society. Okay, and that is a core precondition of forming human societies. We need to meet with each other to achieve a certain objective. And the knowledge pyramid, as you may have already seen in many presentations, So the knowledge pyramid is basically a sharing of data. From data you gather information, from there you gather knowledge, and then you get wisdom. And that is why it is really required that we need to combine with each other. So the more we get to combine this, the more the better. Now the question is that it is not just true about human, it is now true about true about machine wisdom as well, because the machines need to communicate with each other. Machine need to exchange the data. From there you churn out the information. From information you churn out knowledge. From knowledge you churn out wisdom. And that is how you get all the the artificial intelligence and everything working. We'll come to this a little bit later. Now, we have already we were already in the pathway of predicting that there is a fourth industrial revolution. Now what we essentially mean by fourth industrial revolution is basically where everything will be determined by cyber physical systems. So the cyber is important. So cyber means there has to be that we have to have a role play for internet there. So we are talking about all connected machines. I mean, actuators, sensors, communicators, everything. So everybody connected over the internet, and that is what we call, cyber physical system. And before that, starting from the era of steam engine, so we have never talked about this kind of a connected system. We have talked about connected systems in silos, but not this kind of all-pervasive connective system. Now, when we talk about robotics, what is exactly we are talking about? We are talking about a system which will be partially automatic, but not fully automatic. So it will be a system which will take some local decisions, but it will still remain under the supervision of a human master. If you reduce this quantity, I mean, if you reduce the control from here, the more you reduce the control over here, the more intelligence you need to put over here. Okay. So the more complexity you need to achieve, the more complex task you need to achieve, the more the more offloading of intelligence has to be over here. And there has to be a trade-off, a balance between how much you put here and how much you put here, depending on the task and on what you are going to do. Now, what is the data that is going to exchange? So here is a human master. Let us call it a master, and this is the avatar or the robot. Now, this is a typical control system, distributed control system, where the connection is a black box. That is the internet. So sitting at the application, I either know that whether I'm there at the robot application or I'm there at the master side application. So there will be video and audio, because these video and audio are the essential feedbacks for the master to generate the control information. And what is going this side? So this side you're sending position and velocity. If you need to actuate something, maybe the robot needs to move, maybe some limbs need to move. Now, if we really talk about the tactile internet, which is that you want to sense, you want to touch the remote side from here. So here you have to have some kind of a sensing. What is to be sensed is to be told by this side. So the surface and texture information needs to be sensed from the sensors from here. The force need to be sensed and converted to electrical signal at the robot side, and that needs to be converted here at the sensor. So this is more like a AR or VR based games that we see these days. So you get all the feel of running playing with, say, tennis bat, or maybe your gloves is giving you, or your joysticks are giving you the impression of firing. So you feel all the pushback, etc. But those are all localized. Here we are talking about across the internet. We want to send these informations in no time, right? So that is the basically the requirement. So one of the primary requirement is that you need an extremely low delay. And we are really talking about 1 millisecond delay. Now, if you consider the speed of light, so speed of light in 1 millisecond, light can travel only up to 300 kilometers. Now, that's a real challenge, because you then get limited by physics in terms of how much. I mean, within that constraint, what could be the maximum distance between these 2 points, the master and the avatar, right? So we need to really have some kind of an intelligence to get this realized, to overcome the limitations posed by physics. Now there are some other limitations. One is that these avatar devices, so they have to move around, right? They are not something that gets tagged by wire, okay, which are tied by wire. You need to have them as battery powered. They will have low computing power, and they will also have low memory. Now, having said that, that means that you need to conserve the battery, the energy. You need to conserve and you cannot put too much of complex computation over here, because computation will also tell upon the energy, the energy of that you can store, and also the memory that these guys will have is also going to be very low. So you cannot even store a very hi-fi AI model or anything. So that is a constraint. But if you put everything over here, then you will have the best scenario. But the physical the physical the device configurations actually do not allow you to do that. But at the same time, we need certain local decisions under the supervision of the master. So what we are actually talking about, like, so we want to touch the remote environment. So as I gave you the example, like driving a car remotely. So through the gloves, you're going to sense all the entire environment. Now, in this case, it is just a simulation. It is not a real car. The picture you are seeing right now, it is not a real car. It is kind of a gaming console. But what if this console is actually giving you the real-time video of what you are saying on the at the dashboard? Had you been there at the dashboard? And from this side, this is the reactionary kinematic controls that are going to the car to to drive it safely. Now, that is the kind of requirement we are talking about. And for this, it has been seen that if movement of steering and the movement of the wheel, so there is a distance of around 1 millisecond, and that is what we want to achieve through internet. So as if you are moving the steering right there. So that kind of minimalistic delay has to be ensured. How we can do that? That is a big challenge. Now, when we talk about automation, there are few things that we need to actually consider. So first of all, who is going to sense the remote environment? The remote environment is going to sensed by this robot, definitely. So just assume, just consider like having your smartphone. So in that smartphone, what you see a lot of sensors, right? You have got accelerometer, you have got proximity sensors, you have got light sensors, and a lot more depending on the brand you are using, right? So the sensors are to be put here at the avatar, okay? And these sensors, the data, that is going to be fed back here at the human side, either through to the joystick or something that guides how the video is going to be placed. Now, based on these sensors, the robot has to take certain decisions. Now, these decisions are to be taken either at the cloud or at the edge. Now, what is this edge and what is this cloud? Practically speaking, this cloud is actually, you don't know where that machine is. That machine is somewhere. That machine may be in America, in Bombay, anywhere, and you can be at any part of the world. So you have taken a cloud subscription, and it is the responsibility of the cloud provider to serve you with a computing store. And this is not really concerned with with the communication aspects. It is concerned with the computation aspect. So it will give you enough memory for storage of data, and you can get enough computation power from here. Now the question is, definitely, if this is what you are going to use, then you can do a lot of intelligence, a lot more intelligence over here. A lot of complex decision making can be done over here. But at the same time, what is not guaranteed is the latency. Suppose I give a navigation command, I give an abstract command, and I expect that the robot will understand my command and take certain decision. For example, suppose I am developing an application where here I just use my speech and tell the robot that, robot, please go near the bedroom, or please go to the supervisor's room. Now this robot will have to do few things. One is, the voice signal has to be analyzed by this robot, and the robot has to understand that there is a command for this for him or her. And then what is the command? After it understands what is the command, that needs to be translated into a trajectory where this robot needs to travel. Now, who is going to do all these computations? These are very fairly complex computations that needs significant models. So one option is that you put everything to, definitely we are not going to put everything here. We don't have the memory, we don't have the computing power. So who is going to do that? We can put everything on the cloud. But then what happens? You share this command to the robot. Now, before you share, after you share the command and the robot starts actuating, there will be a huge delay, which might be unacceptable. There can be some other examples. You need to, there is a some obstacle or some unknown phenomenon is happening, and from here to send a signal across the internet to this guy might be a little bit difficult. You may not be able to. The signal may not travel in the stipulated time, and in certain situations, the robot needs to act fairly quickly and based on certain complex understanding. Or maybe the robot has to get hold of an object for which it needs to scan the object, understand the complexity, and then hold it accordingly. Okay. All these computations, who is going to do? So one option is that you put everything to the cloud. But if I put everything to the cloud, any localized decisions or any decision for which the master has to wait will be severely impacted in terms of latency, because the latency is not guaranteed, because there is also another internet which is a very unreliable channel in between, right? So the other option is that you put certain decisions at the edge. What is this edge? The edge is basically a computing machine, a computer or a computing device which resides close to the robot's premise. So this can reside somewhere in the operator network. This can reside somewhere within the local Wi-Fi network, and this can even be an edge cloud. And how what that edge cloud means, we'll discuss it later. So the more you put automation, you need these two. Now, one problem with this one is that this will have much less capacity than the cloud. And mobility is definitely a concern. If the cloud is there, you know it is mobile. But if you need an edge very close to you, so if you are out of range, if the robot is out of range with this edge, then you are no longer able to use this edge, because this is always in your local area network or somewhere very close to you, right? So we have to take a logical decision by trading off between several parameters. One is how much complexity you have. Can I divide this complexity between two parts? So some part I put on at the local edge, some part I put on the cloud. So some of the background intelligence that I might need, or some intelligence that I might be doing for some bookkeeping purpose, or maybe for some letter use, I can put in the cloud. In most of the cases, our target will be to put that at the edge. But then comes the question that if this edge goes beyond my radio range, what do I do? So, but in terms of delay, it will definitely give you much more, low latency performance. So in many cases, you can actually emulate some of the commands that the robot needs to actuate here, implying a low latency operation in many cases. Or in many cases, you can actually put some intelligence here which can compensate for loss of commands coming here because of internet congestion, etc. And the robot can actuate. And with this backdrop, on this backdrop, we'll try to now get into 5G and why we are talking about 5G at this point. See, 5G is not just another fat pipe. We have to keep this in mind. So up to 4G, what we had is a kind of a fat pipe kind of idea. So 2G, less speed, less bandwidth. 4G, 3G, higher speed, higher bandwidth. 4G, even more speed, even more bandwidth. 5G, that will be even more speed, even more bandwidth. But that is not the case, or that is not the only case. 5G is actually coming up as a large umbrella that is going to take, that is going to be a single point answer for different applications requiring multitude of quality of service requirements. So on one side, there will be all IoT kind of applications. So for example, when this maybe this guy, the avatar, is sending some sensed information, those are all IoT type information. Okay, they don't need high bandwidth, but they need to be sent very precisely in a very low latency manner. Okay, same for the position and velocity, and the sensed information can actually be generated in bulk, so they can occupy the internet resources at the same time. But 4G and 3G technologies, the physical layer, actual the electronics of those communication technologies are not really suited for this kind of narrowband communications. Okay, so but we need a single answer. So that is why you see on one side there is massive machine type communications, which will allow the sensing devices which require very narrowband communication, but at the same time they they I mean, even if a large amount of sensors or a large amount of data tries to occupy the network, it is not going, the network is going to still handle that. That is one thing. The other side is that low latency and ultra reliability. We are talking about 1 millisecond latency, and and now what we are talking about in 6G and or 5G and beyond, we are now talking about around 625 microsecond latency. So for this kind of actuation, for vehicle to vehicle communication, we need this kind of latency. And the other side, there is enhanced mobile broadband, which is you want to say 8K video. So, which is like, multi-dimensional video, sending multi-dimensional video, holographic video. That is what I showed you at the very beginning, right? So now these are all divergent requirements, and for which we have a single standard for all diverging requirements. But is it all? We are talking about all data rates, latency, network capacity, etc. And that is not really all about 5G. 5G is the first standard from 3GPP, which essentially is a communication standard that allows the network to compute. So, in other words, it means that unlike the existing systems, computing and communication are no longer disjoint. Rather, they are combined. How this combination is going to happen? 5G actually allows you to integrate an edge device deep inside the network. So the problem that we are discussing earlier, that how this decision at the local edge can be leveraged for a mobile environment. If, say, the edge computer is within the Wi-Fi range of this guy, okay, or in a local area network, whatever it may be. So if this moves away beyond the radio coverage, how I'm how this robot is going to access this thing? So this will be a typical dilemma for an application developer. If the application developer writes a code and partitions the logic such a way that some part is going to put on the edge, some part is going to put on the cloud. Now, in reality, maximum of the time, his code is not going to work, his solution is not going to work, because this robot is beyond the reach of the edge. So for this, there is this concept of mobile edge computing, or MEC. So this MEC is going to be an integral part of the 5G. Now, what this MEC can serve? Now, this MEC actually opens an endless possibility. Whatever intelligence you can put here, that might benefit. So what all intelligence can we have? We can use this edge for correcting audio and video before delivering, okay, to the robot, or we can do some special encoding for resilience against channel errors and then transmit to the human master over the internet. We can do some intelligence over here so that some of the information coming out from here can actually be compressed, and only the meaningful part can be sent here, or the relevant part can be sent here. We can use this to guide the robot for certain actions for which you can make a local decision. We can take a local decision. The robot can be guided by a local decision through the intelligence over here. There are plenty of such examples. I'll show you one example in a real life scenario what we have deployed. Okay. So, and also this edge or this edge can also be used to trigger or to analyze how the network is behaving right now if it resides deep inside the operator's network. We are not going to that one at this moment because that is related to how artificial intelligence can enhance the network functions. We are not doing that right now. We are more concerned with the application. So that is basically why 5G is important for robotics. So one way, of course, the latency. So latency means from here to here, all the kinematic and all these decisions, all the actuations are going to take a very minimalistic delay. So that 5G is promising to ensure. And at the same time, all the video and audio, the more higher resolution you can get to, the more precise actions can happen here. You may have some intelligence residing at the master side as well, which can do some decoding on the which can also churn out some information from the video at this end, right? So from there, what you need is a very high resolution and a highly reliable video and audio. So that is something, and considering VR glasses, etc., that is something being touched by this feature of 5G. The low latency feature of 5G is here, and the sensors on the robot are going to exploit these. So you can see robotics is essentially taking advantage of all the promises of 5G. And that is why 5G is so important for robotics. And on the contrary, on the in the I mean, on the other side, the robotics is also a very apt use case or application for 5G. So many of the 5G requirements in future will be derived from the field of robotics or these kind of real-time interactive systems, from which future technologies will also be designed to address those gaps. So how we define automation and robotics? So 5G, of course, 5G is there. Machine learning has to be there. Cloud computing has to be there. And these two will go hand in hand. And there is specialized protocols for IoT. 5G will take a special seat for IoT, or IoT will have a special seat for 5G. And of course, there is mechanics which will actually prepare the robot hardware, etc., the wheels, the balance of robot, the form factor of the robot, and the drift in the robot, and all the electronic circuitry. I should have also mentioned electronics here as well. So that is how the robotics is going to take shape by contributions from all these fields, right? And 5G is playing a pivotal role because 5G is essentially, IoT and machine learning, everything can get into 5G through the, computing aspect of 5G. But we actually did all these things for the first time. When we built telepresence robot in our lab in 2019. But still, I mean, it was like, okay, it's good to have, but do we really need it? So there's no market was really sleeping, but now it is no longer the case because, again, coming back to social distancing, when you try to ensure or you are trying to bridge the divide, robotics is really coming up as a very useful tool in this kind of situation, okay, where human has to maintain the distance but the society has to progress. So that is why I took this use case of semi-automatic robotics where a human has to collaborate with a robot, okay. So um, so right now we have got all these, people are really talking about remote surgery, telepresence, etc. These are the use cases. Now I want to take you through to one of the deployment that we have done. So we have created a solution called teledrive, that is a telepresence solution. And let me take you through the features. Now, this is a patented technology. There is not a single patent, but a multitude of patent. So what you see here, this is the robot, telepresence robot. So it does not have any limbs, but you can remotely, wheel it around, and it has got some sensors with it. So this robot is in one of our associates' premise, and there are, the unique feature of our solution is that you can actually have multiple users. So this is the user whose screen you are right now watching, and they are the other remote users. So all these users can simultaneously log in to a session the same way you have logged into this Google Meet session. So the same way you can log into a teledrive session, and the beauty is that any one of the persons can take control. Just like you see right now, robot status is showing available and free. So that means anyone can try to take control of the robot and become the master. So this is unlike the previous scenario we were explaining, where there was only a single master who was actuating and getting the feedback from the robot. In this case, you have actually multiple people can collaborate through a single robot. So this is a special scenario which we call multi-presence, collaborative multi-presence. Okay, and this technology, we have already filed a patent for this technology, and the patent aspect the technology aspect of the patent that we have filed, I'll describe in a few minutes after this video is over. So right now it is in Rudra's house. Rudra is one of our associate, and so let us see what are the features are there.
Present setup. We have 4 guests with us, and starting with Ashish. Ashish, would you please follow me so that I can show you the entire venue? Okay, I'm going to take the photo.
Right. So as you can see, the operator status, so the robot status has changed as busy, and Ashish is showing as the operator. Okay. So that means Ashish has become the controlling master. Now Ashish has clicked a position on his screen. Okay. So this is on the field of view, whatever view he is getting, on that he has put an augmented reality pin. So it is just like clicking on his screen. He has just clicked on his screen and a pin has dropped. Now the robot, as soon as the pin is dropped, the robot analyzes where that pin is dropped within its field of view, and the robot moves to that coordinate, as you can see. right?
And I am doing manual navigation.
Now you see the robot status has changed. It is still busy, but Ashish has relinquished the control and Snehashish has taken the control. The operator is right now Snehashish.
Hello, I'm going to sing Vande Mataram in the original tune set by Kaviguru Rabindranath Tagore and sung for the first time by Kaviguru Rabindranath Tagore himself in the 1896 Congress Assembly in Calcutta. This tune is quite different than the present day tune in which we hear Vande Mataram as the national song of India.
Hello, are you able to see my screen? Can someone confirm?
Yeah, it's visible.
Okay, okay. Sorry, there was a disturbance in the meantime. Yes, let me go to that. Let me play that video yet again.
Four guests with us. Follow me so that I can show you the entire venue. Okay, I'm going to take the control. And I am doing manual.
So right now, Snehashish is actually using this virtual joystick and controlling the robot in different directions. And this is an interesting feature. So if you have a preloaded map of the premise, so one user can remotely actually put a goal which is beyond the field of view, and the robot moves to that location, understanding where on the map where the coordinate has been dropped. Okay. And oh,
मोहम्मद आए जंग बहादुर
হোয়াটস
योर एक्सेलेंसी
কলকাতা জয়ের সময় তুমি আমার সঙ্গেই ছিলে। কলকাতা জয়ের ইতিহাস তোমার জানা আছে। তুমি জানো সেই নগরীর নাম আমি আলীনগর রাখি।
जाने योर एक्सेलेंसी
আলীনগরে তোমাদের কোম্পানি
so I hope you can see it right now. So the last example was that uh, the so one person he was there at Delhi. He kind of gave the instruction that go to the table, and the robot moved to the table. Now let me come to the architecture, how everything was possible. So I'll try to discuss this in a very broad way so that you understand where 5G is going to have a role play. Now this entire demo that I showed you was not really a built on 5G. but it has the potential to be built on 5G. And we actually experienced a lot of latency, about latency in the order of 120 milliseconds or something like that. So as you can see, there is a combination of cloud and edge. Okay, so there is one edge and there is also a cloud. So now try to relate this with what I discussed earlier. So we are having the robot at one end. There is an edge connected in the local area network through Wi-Fi with the robot. Robot has got the edge interface through which it gets to connect with the edge for all the navigation and understanding the speech, etc. So, in order to reduce the
Excuse me, sir.
latency, yes,
Sorry for disturbing, but sir, your screen is not visible to us.
just a moment. Okay, let me stop share, try to share again. Okay. Are you able to see now?
Yes, sir.
Okay. So as you can see, there is a cloud which is we took it from Amazon. There is a session manager. There is some kind of storage, and there is also a media engine residing here. Okay, and the rest of
Double is a remotely controlled mobile teleconferencing system that enables conversations to happen anywhere, anytime. It's the ultimate tool for telecommuting.
so
To move around, Double
now
uses a gyroscope and accelerometers, the same concept as a Segway. It's very stable and won't tip over easily. The self-balancing algorithm will correct itself and do its best to remain upright. You can change the height of your double remotely to match the eye level of those you're interacting with. Double also has 2 kickstands so that you can stay in one place when you need to. There's a mirror on your double that lines up with the camera on the back of your iPad so that your second viewing angle is the ground directly around your double. This is
so it seems like somebody took control and started presenting. Anyway, but in our case, it does not happen. The robot is you get an exclusive control on the robot. Anyway, so now the question is that this the WebRTC client. Now, if you go to any market and buy, say, the exact hardware that we are using, that was taken from Double, okay, the Double Robotics, and we use some of their libraries. But what they don't provide is the intelligence through which you can actually do a connecting a multitude of people. Just like we are connecting over Google Meet, and all these people are connected while anyone can start sharing the screen, right? In case of the off-the-shelf products, what happens is they allow only one-to-one connection between the robot and a single master. Now, what would happen if, just like in this case happened, that somebody took control and started presenting, dislodging the presenter? That will cause a catastrophe in such a scenario. So that is why we have created a patent filed technology where you can create an on-demand, end-to-end encrypted peer-to-peer communication channel while all your media, that is audio, video, etc., can travel over the cloud. Okay, but this peer-to-peer media travels directly between the two nodes, and that is where the TCS solution actually is much ahead of the existing products in the market. Furthermore, none of the existing solutions will actually have this kind of an edge computing. with it. Okay. But in this case, you create an edge interface through which, and that is why we can do all these kind of intelligence. For example, when the robot is downloading a map and the